All right, proving identities, question number 40. Now, again, if you want to make one side look like the other side, you're going to pick the more complicated side. Now, again, these both look very complicated, okay? And certainly we could do some distribution there, okay? And see if we could divide out any, we're going to have a whole bunch of terms there though. Usually expanding, sometimes expanding doesn't simplify. If you expand and it's like a secant times cosecant or something where they would make one or something like that and make it simpler, that's a good idea. But I wouldn't suggest this side. I would look over here and you know what? I'd say there is an indicated operation here, this adding. I would try and do that. And the reason why I would focus on the left side here instead of the right side is because look at this. In order to add, you have to get a common denominator. So that means that we have to multiply these two things together to get a common denominator. And again, what does that give us? That gives us a difference of squares. It's perfect. Okay, so here we go. So what I'm going to do, let me just erase this so you can see. So I am going to multiply this side by 1 plus cos theta, top and bottom. Okay, and on this side, I'm going to multiply by 1 minus cos theta, top and bottom, to get a common denominator. So now, I'll change colors here because we're going to run into each other. So the common denominator now is 1 plus cos theta times 1 minus cos theta, right? And on the top here, we have, what's this when I multiply this out? What's that going to be? That's going to be sine theta times, sine theta plus, not times, plus sine theta plus sine cos theta. Sine theta cos theta. And over here, this is going to be 1 minus cos theta. Okay, so okay. So now this looks like it's a little more complicated, but look at actually how close we are now to the other side. See, and you can actually when you get practiced up on this, you can kind of look ahead a bit. So look at this. I'm looking at this right here. This is going to be a difference of squares, which is actually going to be 1 minus cos squared, which is actually going to be equal to sine squared. So right now, this actually equals this already. We have this part and this part exactly the same. This is just the factored version of this, you see? So we're actually really close already by doing this indicated operation. So let me just finish this up. So I am going to factor these two. I'm going to take a sign out. I'm going to be left with 1 plus cos theta. And I'm going to leave all this alone. Plus 1 minus cos theta. And then you see that that's exactly the same as the top on the other side. When you multiply this out, you get a difference of squares of 1 minus cos squared theta, right? You do the FOIL method, right? And you get a difference of squares. And then finally, you're going to see that this is going to come into play. 1 minus cos squared theta is actually equal to sine squared. So be sure to show your work, okay, like this. Show all the steps. Don't put too many steps together because I need to see that you're transforming your pieces of the expression. You know, I need to see what you're doing, that you know what's going on, okay? Sine squared cos. Okay, so now if we look at carefully, this side equals this side now. Okay. And there you have number 40. Now, if you went back the other way, I guess you could kind of see, you know, if you wanted to think about going backwards to transform this side into that side, I guess what you would do is you would change the sine squared into 1 minus cos squared. Okay. You would factor this, right, up to here. And then it gets a little bit tricky from there, to tell you the truth. Then you'd have to multiply this in to get this right here. And then you would have to separate. You'd have to go, yeah. See, I wouldn't do that. That gets a little bit tricky, but you're pretty close. You're pretty close here. Yeah. So definitely combining the terms that are, you know, performing the indicated operations. That's always a good thing to do. Okay. All right. There's number 40.